Hey guys, welcome to Safi Mixed. Let us use the information of a circle and find an unknown angle subtended at the center by an arc of an inscribed triangle ACB, like the one you see on the screen. So to understand this, let me begin by drawing a circle whose center I am representing with O, and I take 3 points which I denote with A, B, C. Then I join point A to point C and point B to point C. The angle subtended at point C I denote with alpha. Then I join point A to O and similarly point O to point C. Since OA equals OC and each of them equals the radius of the circle, therefore the triangle AOC is in fact an isosceles triangle, and we know for isosceles triangle the angle made by the equal sides with the third side are equal, that is the angle AOC equals angle OCA equals theta, and I denote this in the figure with theta at this position. The same is true about this angle. This angle is also equal to theta according to equation 1. We also know that the sum of all the 3 angles of a triangle equals 180 degree. Therefore, angle OAC plus angle OCA plus angle AOC equals 180 degree. From this, I can write angle AOC equals 180 degree minus this whole angle. That is, I'm taking this part to this side of the equation. Now, using equation A, I can put the values for this in this equal to theta. And doing that, this equation reduces to 180 degree minus 2 times theta. And I give this equation 2. Now, I join point O with point B, and again OB equals OC and each of them equals the radius of the circle. So the triangle BOC is again an isosceles triangle, and using the same procedure like we did for the triangle AOC, I can write angle OBC equals angle OCB, and I denote that with phi, and I put that word here. So I gave this equation 3. Now again, summing up all the angles inside the triangle BOC, I can write the sum of these 3 angles equal to 180 degree, and arranging for angle BOC, I can rewrite the equation like this as I did before, and using the values from equation 3, I can put phi over here, phi over here, so this would make 2 phi. That would reduce the equation finally into this form, that is the angle BOC equals 180 degree minus 2 phi, and I give this equation 4. Now we know that the total amount of angle around a point like this one is equal to 360 degree, and there are 3 angles. One is this one angle, the other is this one angle BOC, and the third one is AOC. So the sum of these 3 angles would equal to 360 degrees, and that's what I am writing over here. Angle AOB plus angle AOC plus angle BOC equals 360 degree. And I can arrange the equation into this form by taking these two to the left side, to the right side of the equation, and substituting the values from equation 2 and equation 4 at this position. I can write this as, I have rewritten it again, so let me put the values, then I can write it like this: 180 degree minus 2 theta from equation 2, and 180 degree minus 2 phi from equation 4. 180 degree would make it 360 degrees, and that 360 degrees cancel with this 360 degrees, so this equation can be written as this when I have removed the brackets. So this become plus, this become plus, like I'm writing over here. This cancels with this, and I can take 2 common from these 2 terms and can write them like a single term this way. Now if I look into the figure, theta plus phi equals alpha. That is, the sum of these two angles is in fact this total angle. So I can rewrite the result as 2 alpha. That means that angle AOB equals 2 alpha. In other words, an inscribed triangle in a circle subtends an arc of length twice the angle subtended by the triangle at point C. So this is a general rule that an inscribed triangle subtends an arc of length twice the angle subtended by the angle at point C. If you haven't yet subscribed to Safi Mix, kindly support the channel by pressing the subscribe button and also the like button on the video. Thanks for watching.